Hey everyone, this is Karthik Chilkapati from Georgia Tech. I'm going to be presenting our Physics 2211 Lab 1. So starting off with the introduction, the purpose of this lab is that we are trying to compare computational and observational motion of an object traveling in constant velocity. So for this, fundamental physics principles that we are using are Newton's second law because we are assuming that our F net is going to be zero. So if our F net is zero, that basically means that our position update equation, which is originally velocity final equals velocity initial plus F net over m times delta t will turn into V final equals V initial. This makes sense because our goal of this experiment is to track something going through constant velocity. So our initial and final velocity should be the same. And then using that, we are also going to be using our position update formula for position final equals position initial plus V average times delta t. Our V average will just be our normal velocity because we have constant velocity throughout. Our system in this experiment is going to be a bottle, and our surroundings are going to be everything around it, which basically means the table, the hand applying the force, and etc. Because this equation has our initial and final velocities being equal, we will know that our final graphs for position versus time are going to be a linearly increasing or decreasing straight line. So first of all, looking at the observational part of this experiment, our initial conditions for the for the bottle here are going to be that the position is going to be this very small number because I set my axis to about right here. And our velocity at 0.017 seconds is negative 4.3 times 10 to the negative fourth meter per second. Here's the motion of the water bottle. Taking this video of our bottle moving, I uploaded this into Tracker and then generated a position versus time graph in the X direction. I first calibrated the video by setting this distance to how much ever it was in real life, and then I set my axis to the starting point and started tracking the center of the bottle from there on until it stops moving. So here, this generated for us a position versus time graph. We can see our constant velocity part is going to be about right here where there's almost a linearly increasing line. And here is our velocity versus time graph in the x direction. We can see we have a relatively constant velocity in the x direction. For our computational model, glow script was utilized, and basically over here for the ball's velocity and ball's position, I updated the equation to make it our velocity update and position update formula. But since our fnet is 0, I created an fnet vector to have a vector of 0, 0, 0 in the xyz directions. And our delta t is going to be 0.0165 because of how many frame. Our total time throughout this video that the bottle was in constant velocity was zero point 0.8 seconds. And then I took the frame rate or how many frames there were in this total video, and there were about 190. So using these two numbers, I calculated that our time step between each delta t should be 0.0165 seconds. And I placed for time less than 2.7 because that's when our constant velocity ends. Bringing our observational data from Tracker and computational data from the code, I generated a position versus time graph for both of these computations. This red line here is the predicted motion we see from our code that I just showed on the previous slide, and this blue line shows what we found in our Tracker video. Both are per se pretty similar, but there could be error because of how the axes weren't exactly lined up to the bottle's motion, which could make it look like it's changing direction while it's traveling. We also eliminated that there are other forces acting on the bottle for sake of this experiment, but there are other forces like friction that can possibly cause this curving of our observed position. So going to our essential questions in the end. So what if the axes were changed to be flipped? So for say our bottle will be traveling in the negative x direction. So if that's the case, then we can see that on this graph, it would be the same slope, except that it would be going from this top left corner down to the bottom right. This is because this would be going in the negative x direction, so the direction would be changed. And for the second essential question, can we say how many pushes and pulls are added to make our net force 0? This is very hard to interpret because we do not know the total magnitude and number of forces acting on this bottle. We can assume that there is going to be the force from our hand pushing it and then friction, but there could be other external factors that we are not aware of. So therefore, we cannot for say sure how many total forces are acting on it to make it net zero, because there are multiple external forces that we may have not considered. And that's it. Thank you for your time.